So we're going to look at velocity and other rates of change. This might remind you of the free response questions about related rates. So this is good. This is a very, very important and maybe difficult subject. So we talk about this a long time, huh? Maybe. So let's see. The first thing is, it says find the area of a circle as a function of the radius. This is actually super easy. All it means is write an equation for the area of a circle. The only variable that you don't, so like area would be pi r squared. That's all that means, because I have the area and it's in terms of the radius. That's what it's a function of the radius. That's all that means. So there you go, done. So anytime it says find something with respect to, or like with a function, or as a function of something else, all you're doing is writing a formula for that thing. Like this formulas that you would look up. So if it said write a formula for the volume of a box in terms of length, width, and height, then you're just writing the volume of a box. So this is part B. Find the rate of change of the area with respect to its radius. Remember, the derivative is also a rate of change. And if we want to find out the rate of change of the area with respect to its radius, then we can just take this and then take the derivative with respect to the radius, respect to its radius. Okay, ddr. So really, I'm taking the derivative with respect to r. This is actually a little bit of implicit differentiation, but we're going to subdue that fact right now. So I'm going to take the derivative of both sides. Here, dA dr would be, the derivative of this, that's just dA dr, times the derivative of the inside, like normal, or so you take the derivative like normal, that would be just 1, and then you tack on a dA dr. But if you don't understand that, then that's fine. This would just be dA dr, that's the rate of change of the area with respect to the radius. That's what that means. And then pi is a coefficient, so I don't really do anything with it. And I'm taking the derivative of r, so I'm pretending like that's an x, and then I just use the power rule. So this would be 2 times pi r, and then I would subtract 1. So then, there you go, 2 pi r. That's the rate of change of the area with respect to the radius. And that's for any radius that makes sense to plug in. Then, so let's think about this. Gives me the formula for the rate of change. So at some radius, if the radius is 4, then the area at that instant is changing at some rate, and it's given by this formula. That's what the derivative tells us, the rate of change. The instantaneous rate of change, actually. So here it says evaluate the rate of change of A, so the area, at r equals 5. So this is effectively asking, when r is 5, how fast is the area changing? That's what it's saying. So if I evaluate this, I just plug in 5 to that, which would be 10 pi. Now what are the units? Well, we'll think about that in the next one. And then if I plugged in 10, that would just be 20 pi, whatever that is. The last step for this is to write our units. So let's think about this. Well, I suppose we weren't given units for area or for the radius, so we have to decide. All right, what would be appropriate for the radius? So suppose we say r in inches. So if r is in inches, that means a is in inches squared. All right. So that's r is in inches, and that means area is inches squared. So if I'm doing the rate of change, that would be inches squared per, what, inch? So then we would just say 10. This is a weird thing because they're both inches and inches squared, so you might like cancel them out. But the area is increasing at a rate of 10 pi inches squared per, so this is for area. I'm not going to simplify, that's why I'm writing for area. Per inch in radius. So, I mean, it's a weird unit, but that's because usually we have like a time and then some other thing, but we have inches and then inches squared. So this would be, well, it's increasing at 10 pi, which is close to 31, 31 inches squared of area for every inch of radius. That's what it's saying. So it'd be, and then this would be 20, same thing. Pi, 20 pi inches squared. So the area increases at 20 pi inches squared, which is about 62. Is it? Maybe? I don't know. It increases at that rate, so 20 pi inches squared per inch of radius. So if you increase the radius by 1, then you're increasing the area by 20 pi. That's what it's saying. All right, that's the end of that example.